You know, inside every single piece of modern technology, I'm talking about your phone, your car, even a satellite orbiting the Earth, there's this incredible unseen nervous system. It's this complex network that literally brings these devices to life. And today, we're going to pull back the curtain and see how it's all designed and built.
So let me ask you a question. What do your smartphone, a self-driving car, and a smartwatch all have in common? I mean, really think about it for a second. On the surface, they seem like they're from completely different worlds, right? But they all share this fundamental, kind of hidden secret. It's the one thing that lets them think and talk to each other and do all the amazing things they do.
And that secret is, they all have an electronic nervous system. It's this super intricate, meticulously designed foundation that tells every tiny little component what to do and when to do it. And that foundation, well, that's the hero of our story today.
All right, so let's dive into the absolute fundamentals. What is this electronic backbone really? And why is it so incredibly important for, well, pretty much everything from your coffee maker to a spaceship? It's called a printed circuit board, or PCB for short, and it is, without a doubt, the foundation of any electronic device. The best way to think about it is like a city grid for electricity. You've got these tiny little copper pathways that act like roads, and they connect all the critical components. You know, the processors, the memory, the sensors, so they can all talk to each other and work together in perfect harmony.
So, how does one of these incredibly complex boards actually get made? Well, it doesn't start with copper and fiberglass, that's for sure. It starts as a purely digital blueprint, just an idea in a designer's head that gets brought to life using some unbelievably sophisticated software.
And that journey from an idea to a real circuit is a pretty structured process. First, you have the schematic. That's the logical blueprint. Then designers figure out the physical layout, deciding exactly where every little piece will live. After that, they have to route all the connections, and finally, they generate the files that a factory can use to turn this digital design into a real physical board.
So that first step, the schematic design, is almost exactly like an architect creating a blueprint for a house. This document shows all the electronic parts and how they're logically connected. You know, this resistor connects to that chip, which connects to this capacitor. But here's the key thing. At this stage, it says absolutely nothing about where those parts will physically sit on the final board. Now, this is where that abstract blueprint starts to feel like a real puzzle. In the layout phase, the designer takes each component and physically places it onto a digital version of the board. It's honestly like a high-stakes game of Tetris, because they have to think about physical size, how to get rid of heat, and how to create the shortest, most efficient paths for all that electricity to travel.
And here, this is where it gets really cool. The 2D layout gets transformed into a full 3D model. This is such a critical step. It lets designers see exactly how the board will look, and maybe, more importantly, if it will actually fit inside the tiny, cramped shell of a smartwatch or a drone before a single physical thing gets manufactured.
Now, as you can probably imagine, managing this whole process, from that abstract blueprint all the way to a photorealistic 3D model, it's just mind-bogglingly complex. And that's where specialized software comes in. It has completely revolutionized a field that, believe it or not, once relied on painstaking manual drafting and a whole lot of guesswork. Modern PCB design software isn't just one tool. It's an entire ecosystem of solutions all rolled into one. Instead of having to juggle a bunch of different programs, designers get a single, unified environment. They get those powerful 3D tools we just saw, advanced routing that can automatically figure out the best way to draw complex connections, and even tools that let entire teams work on the same design at the same time, in real time. It's amazing. But one of the biggest time savers, a total game changer for modern engineers, is a feature like this, manufacturer part search. Instead of having to manually draw and model every single tiny component, designers can connect directly to supplier databases. They can find a real-world processor and with just one click, import its schematic symbol, its physical footprint, and its 3D model right into their project. This saves countless hours of tedious work.
So, what's the big picture here? All these advancements in software, they're not just about making a designer's life a little easier. No way. They are the hidden engine that enables the incredible technological innovation we all see and use every single day.
Just look at the impact across different industries. In consumer electronics, the whole game is about making things smaller and getting them to market faster. Well, this software just crushes those design cycles. In the car world, where safety is everything, these advanced tools help ensure that things like self-driving systems are unbelievably reliable. And for the Internet of Things,
This is how you pack a wild amount of technology into the tiniest little devices imaginable. This quote here really hits the nail on the head. The precision required in PCB design cannot be overstated. As our gadgets get more and more powerful and tinier, the margin for error shrinks to basically zero. This means these advanced design tools aren't just a nice to have, they are absolutely essential for creating the technology we all depend on.
Okay, so we've seen what a PCB is, we've walked through how it's designed, and we've looked at the amazing tools that make it all happen. But what does this all mean for the future? I mean, where is all of this heading?
At the end of the day, it really all boils down to this. Software has become the invisible engine of hardware innovation. By letting engineers design faster with more precision than ever before and letting them test really radical ideas in a digital world first, these tools are what's powering the next wave of progress that will for sure continue to shape our world.
And that really leaves us with a fascinating question to think about. As technology just keeps marching forward, bringing in things like artificial intelligence and super high-speed 5G, the complexity of these electronic nervous systems is only going to explode. So the real challenge for the next generation of designers will be to create the unseen backbones for a world that we can't even really imagine yet. Thanks for joining me.